Okay, so today we're going to be going over synthetic division. Last thing we did was long division of polynomials. This time we're going to do synthetic division of polynomials. It's kind of a little shortcut to help us out when we're dividing. So first thing we're going to start off right here. We have a polynomial up here, ax to the n plus bx to the n minus 1. And notice I ordered it based on the power up here all the way, and I just put dot, dot, dot for whatever's in between because I don't know what n is in this case. This is just an example that I'm using, our template, to dx to the 0. So for whatever coefficient to eventually to get to that final x to the 0, which is just going to be 1. So that would be d. Okay, divided by x minus k. It's really important. In synthetic division, you can only divide by a monomial that has a 1 as the coefficient for the x. So it always has to be in the style of x minus k. Very important. You can't do regular synthetic division unless you do that. Okay? So I have a little example here that I want to show you first before we use any numbers. If you want to challenge yourself, try to do the problems with just using this explanation. I'm also going to do an example afterwards, but if you really want to challenge yourself, try doing it with just this, just based on the template first before you see any examples. Either way, as long as you know how to do it, that's all that matters. So let me explain this real quick. So what you do is you take this k that was right here and you put it off on the side on this bracket, basically, that I made. Okay? And then right here at the top you have the coefficients of the dividend. This dividend is up here. So I just took the a, the b, the whatever, the dot, 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 whatever is in between there, and then I took the d and I just kind of put it right up there. So those are the coefficients of the dividend. From there, a really important rules to know for this is if you're going to go vertical with this, you have to add. Okay? In this case, a plus nothing, so I'm not going to really add anything here. I'm just going to drop down the a. Okay? If you go diagonally, you multiply. So if you see right here, I'm going diagonally up. So I'm going to multiply by this k factor right here. So I'm going to, not factor, but I'm going to multiply by k. So a times k, I'm going to put the ka right here. Diagonal and multiply. Okay, vertical, b plus ka. I'm going to drop that down here. Diagonal, I'm going to multiply by k and put the answer here. Add whatever coefficients right here. Drop it down, diagonal multiply, and then whatever I have at the end, when I get to that d term, that's going to be considered your remainder. And then you have to take all of these coefficients of the quotient, basically, and put them back together to get your final answer. So that's how to do it with just using the abstract formulation before I even show you an example. If you're kind of confused on that, that's okay. I figured you might be, so I actually have an example right here all set to go to show you how to use what I just went over right here. Okay? Here we go. So first thing I'm going to do is I'm going to write down the coefficients of the dividend, which is this 1, this 2, and this negative 8. So I'm just going to write it right here. 1, 2, negative 8, just like that. And then I'm going to make my bracket like so, just to match what I did over here. And then it says x minus 2. So in this case, k is 2. And we can use synthetic division on this because if you notice this is a monomial and it has a coefficient of 1. So it's perfect for what we want to do. So we have the 2 here, and again you just drop down the 1. So I'm just going to put the 1 here, just like we did over here, drop it down. And then I'm going to multiply and move it diagonally. So 2 times 1, in this case I'm going to put the 2 right here. So that's how we get the 2. 2 times 1, we get the 2 here. So then you have to add now if we go vertically. So 2 plus 2 is 4. So I'm going to put the 4 there. Okay. Now I'm going to go diagonally over here to fill in this spot right here. So I'm going to multiply the 2 to 4 times the 2, and I'm going to get the 8. Vertically I add, so negative 8 plus 8 is 0. And our remainder is 0, as you can see right here. So now what you do with this is these are the coefficients of the quotient. So I'm going to actually make the answer based on these coefficients. So this first one will be the remainder, and it's 0, so we don't have to worry about that. This next one is going to be the x to the 0th power coefficient. So in this case, it's just going to be 4. Because x to the 0 power is just going to be 1. So it's 4. This one is going to be the x to the first power. So in this case, it's just going to be x. So your answer ends up being x plus 4, because it's the 1 coefficient here, and then the 4 goes right there. And that's basically our answer for using synthetic division to divide polynomials. Okay, now you might think, when are we going to use this? What's the whole point of this? There is actually going to be a reason that we're going to be using this when we're figuring out the zeros for polynomial functions. But for now, this is just a good skill to have until we get to that point in the lesson. If you have any questions, let me know.